Hi girls, today we are going to see about electromagnetic waves, the fifth chapter, and here the electromagnetic waves introduction. And when you see the lightning photo here, that means everything in the space, they consist of so many electromagnetic waves, and there are 7 parts in the electromagnetic waves. We shall see that now. So when you see light from the sun is one of the sources of energy without which human beings cannot survive in this planet. So the first source of the first example for electromagnetic waves we shall take from the known one, that is light. So without light we cannot survive in the world, and here without light even we cannot see the objects. And so here light is an electromagnetic wave which moves with a speed equal to 3 into 10 power 8 ms power minus 1 in space or vacuum. And here light is an important example of electromagnetic wave, and its velocity is a constant one, which is equal to 3 into 10 power 8 ms power minus 1, which is the highest value of velocity in this world. And here there are so many waves in electromagnetic spectrum, from gamma rays to radio waves. And so here the time varying magnetic field produces an electric field, which is Faraday's law of electromagnetic induction, that we have seen in the 4th chapter. And so here Maxwell, the scientist who believed in symmetry, he raises a question. He raised one question: when the time varying magnetic field produces an electric field, why not the time varying electric field produce a magnetic field? That is a very important question, and this question gave a way to find out the electromagnetic spectrum. And in nature, when you see the butterfly, the leaf, they are symmetry in nature. The left hand side, right hand side, they are symmetry in nature. And so also in the case of electromagnetic waves, the change in electric field produces magnetic field, and vice versa. And so this is experimentally verified by Maxwell. And important one in that is, in that invention, laser, radar, they used these electromagnetic waves in many ways. And laser is a acronym for light amplification by stimulated emission of radiation, and radar means radio detection and paging. They uses the electromagnetic waves. And here you have seen a diagram here: cell phone tower, cell phone, X-ray radiograph, all these they work on the principle of electromagnetic waves. And so here in communication they play a very important role, and also even the online classes can be possible only with the help of electromagnetic waves. And X-rays, they are used for detecting the bone fracture, and for cooking you can use microwave oven, and laser surgery. And also you are known with the radar signals, which are used in all the aeroplanes and in military services, etc. And next we are going to see about displacement current and Maxwell's correction to Ampere circuital law. And we have seen about Ampere circuital law in the 3rd chapter, and Maxwell made one important correction in this Ampere circuital law, and in that way he found out the displacement current. So here the changes in magnetic field produces an electric field, and here you see this equation: integration over L E vector dot dl vector is equal to minus d by dt of phi b, and this is according to Faraday's law. And instead of phi you can substitute integration over a surface area b vector dot dA vector, because phi equation, phi is equal to integration over a closed area b vector dot dA vector. This is substituted here. So here the electric field is related with the variation of magnetic flux, and this variation in magnetic flux they relates electric field. So this will take place in all cases. And here phi b is the magnetic flux, and d by dt is a total derivative with respect to time. So these are the main concepts in this Maxwell's correction. So for symmetry considerations, in equation 1 you can substitute instead of electric field a magnetic field, and a magnetic field to electric field, you will get this equation. So integration over L b vector dot dl vector is equal to minus d by dt of phi is equal to minus d by dt of integration over a surface area E vector dot dA vector. This is following symmetry consideration. And here, so the magnetic field is induced along a closed loop by changing electric flux in the region encircled by that loop. This is very important point in this part. And here next we are going to understand about displacement current, that is Maxwell's correction. And for that you consider a wire which is shown in the diagram. The wire carries a current, and positive plate and negative plate of the capacitor is given, and this is shown by the loop. So this yellow region just represent a capacitor, and when current passes through this, the capacitor gets charged. And here we have to find out what is magnetic field at the point P, which is outside the capacitor. For that you consider an Amperian loop with a surface area S1, and here IC is nothing but the conduction current which passes through the capacitor. And here, so to calculate the magnetic field at a point P near the wire and outside the capacitor, let us draw an Amperian loop which encloses circular area S1. So you are now writing Ampere circuit law, integration over a closed surface S1, B vector dot dl vector is equal to mu naught IC. Here mu naught, you know, permeability of free space, and IC is conduction current. And in this diagram we are considering another surface area S2, which is a balloon shaped one shown by the blue region, and S1 S2 will have the same boundaries, only the shape is different, and this encloses the positive plate of the capacitor, and the conduction current is as usual it is flowing. And so when you see, the Amperian loop does not depend upon the shape of the enclosing surface, so the left hand side will be the same one. So integration enclosing S2 B vector or dl vector which is equal to 0. So in this equation the left hand side remains the same, but the right hand side becomes 0. Why? We shall see now. So here because there no current flowing between the plates of the capacitor, that is the main reason. That is, when you see these two plates, there is gap between the two plates, positive plate and negative plate, and there is no current flowing through this because a dielectric is placed in between the capacitor, and because of that in this equation the right hand side becomes 0 because IC is equal to 0. When you compare the two equations 5.3 and 5.4, there is some inconsistency, and so there is assumed that while the capacitor is being charged up, the varying electric field is produced between the capacitor plates. So when you see here, when the capacitor is charged, then there will be varying electric field. Definitely that will produce the current called displacement current. So this is the displacement current found by Maxwell. And so apart from conduction current, you are also having another current known as displacement current. And so he introduced some change in Ampere circuit law. So when you see the equation, phi E is equal to integration over surface area E vector dot dA vector, and this is the dot product. After integrating and applying theta 0, you will get EA, which is equal to Q by epsilon naught. This is according to Gauss law, which you have studied in the first chapter. And so when you differentiate this equation, d phi E by dt is equal to 1 by epsilon naught, because epsilon naught is a constant, so it is taken outside, 1 by epsilon dq by dt, and bring this dq by dt this side, you will get dq by dt is equal to epsilon naught d phi E by dt, and this dq by dt is rate of change of charge, which is equal to displacement current. So id is equal to epsilon naught d phi E by dt, and this is nothing but the displacement current. So how can you define displacement current now? The displacement current can be defined as a current which comes into play in the region in which the electric field or the electric flux is changing with time. So whenever the electric field or flux changes with the time, definitely you will have some current, and this current is termed as displacement current. And in the equation, instead of I, you substitute IC plus ID, that is, it is a summation of both conduction current and displacement current. And when you remove the bracket, you will get mu naught IC plus mu naught epsilon naught d phi E by dt, substituting for ID. So this is the correction made by Maxwell, and so together this equation is called Ampere-Maxwell law. So here the displacement current or time varying electric field also produce a magnetic field between the plates of the capacitor. When you see this diagram, in between the two plates, positive plate and negative plate, there is an electric field, and apart from this electric field you are having another circle in between these two. This circle, which I have represented by red arrow, is nothing but magnetic field. So this electric field and magnetic field, when you see the direction, they are perpendicular to each other. Electric field is from left to right, whereas this is from top to bottom. So they are perpendicular to each other. Next, importance of Maxwell's correction. So the earth receives many radiations from sun, and they enter through the space which there is no electric charge, and where there is no electric charge and no electric current. So without electric current there will not be any radiation, but that is not possible. So the Maxwell's correction is very important, because a time varying electric field or displacement current can also produce a magnetic field. So even if in the space the conduction current is 0, there will be displacement current, and this displacement current produces radiation. And so in this equation 5, 6, the term IC becomes 0, because in space there is no conduction current, there is only displacement current. The equation becomes integration over L B vector dot dl vector is equal to mu naught epsilon naught d phi e by dt. So when you see in stars, because of high temperature there will be time varying electric field, and this produces in turn the time varying magnetic field. So there are two fields, electric field and magnetic field, they couple together and they form electromagnetic wave which moves with the speed of light, and this is called electromagnetic wave. So here there must be the electromagnetic waves in space, and this Maxwell correction is very important for proving the existence of electromagnetic waves. Next, Maxwell's equation in integral form. So Maxwell's equations are given in 4 forms of equation, and so here though they are in integral form and derivative form, we are using only in this portion the integral form of Maxwell's equations. And we shall see the first equation. The first equation is nothing but the Gauss law of electricity, that is integration over the surface area E vector dot dA vector is equal to Q enclosed by epsilon naught. This is nothing but Gauss law for electricity. And so here E vector is electric field and Q is the enclosed net charge by the surface S. And this is for both discrete and continuous distribution of charges. This shows that the lines of force starts from positive charge and terminate at negative charge, and also the lines do not form a continuous closed path, which shows that the isolated positive charge and negative charge can exist. So in the case of electricity, the isolated positive charge or negative charge can exist. But in the second equation, this is Gauss law for magnetism. In this part, the right hand side becomes 0 because it does not contain any charge. So integration over surface area B vector dot dA vector is equal to 0. This is Gauss law for magnetism. And here this shows that there must be a continuous closed path. In other words, there is no isolated magnetic monopole exists. So here no south pole or north pole exist separately, or there is no isolated magnetic monopole exist. Only the north pole and south pole exist in pairs. So that is the second equation of Maxwell. And the third equation nothing but Faraday's law of electromagnetic induction, that is integration over L E vector dot dl vector is equal to minus d by dt of phi b, and this is nothing but Faraday's law of electromagnetic induction. And you know here E vector is electric field and d phi by dt is rate of change of magnetic flux. So this magnetic flux produces the electric field. And so here the fourth equation is already we have studied in this portion. Ampere Maxwell law is the fourth equation, and according to this equation, integration over L V vector dot dl vector is equal to mu naught IC plus mu naught epsilon naught d by dt of integration over surface area E vector dot dA vector. Here we have substituted instead of phi e, I have rounded and shown you integration over closed area E vector dot dA vector. We have just substituted for phi E. This is Ampere-Maxwell law, that is a combined form of both Ampere and Maxwell. So here not only the conduction current but displacement current can also produce magnetic field. That is the main concept here. So the entire communication system in the world depends on the electromagnetic waves, the stars, galaxies, planets, and other mobile communication, TV communication, radio communication, etc. Every communication they need the electromagnetic waves. Hope you understand, girls.